In this set of slides, we talk about the asset and liability sensitivities. So the next step requires setting the sensitivities of asset and liabilities versus the factors that we've been talking about. The sensitivities describe how much the value of the assets and liabilities move in response to a move in the corresponding factor. For the assets, the bond values are sensitive to changes in the real rate, inflation, and the nominal bond premium. Equities values are sensitive to changes in the real rate and the growth rate of dividends. And you can see the corresponding formulas there. This is the value of bonds is equal to the sum of the cash flows in time t divided by 1 plus the rate in time t to the power of time t. The value of equities is equal to the dividends divided by the rate minus the growth rate. From the formulas, we can derive the sensitivities versus the underlying factors. For example, bonds with an N, or a time, is equal to 5, and a par yield, or rate, of 5.5%. If the actual short-term risk-free rate moves by 100 basis points, the yield of a 5-year bond usually moves by less. The market assumes future short-term rates are close to the average. When mean reversion is assumed, the corresponding bond value function is flatter than in the case of no mean reversion. A decrease in the bond value of approximately 2% in response to a 1% increase of the short-term rate. For accrued benefit liabilities, we assume no inflation index, so the accrued benefit liabilities cash flows will be fixed in a market-related sense. So the model looks identical to a bond. Because we deal with very long-term bonds, and hence the key risk is a change in the discount rate. For future wage benefits, they're driven by wage inflation and real wage growth. So it has the same core structure as equity, but also a correction factor. For wage inflation, because the inflation factor is only relevant between now and retirement, we need to use an actuary's estimated time to retirement of the active population, which is 11 years. Any change in inflation from the assumed rate would compound itself on average for 11 years if the change in inflation persisted that long. Because we assume that inflation reverts to the mean over the median term, inflation changes have little impact. For future real wage growth, sensitivity to changes in future wage growth is approximated by average future service of 11 years, as future real wage growth only applies until retirement. But we assume changes in growth to persist for longer than we assume for inflation, so it has a higher sensitivity. And with regard to the discount rate, we recognize that the cash flows in the case of future real wage growth are equity linked prior to retirement and fixed thereafter. As a result, the cash flows are similar to both equities and bonds, and thus the corresponding discount rate should reflect both the bond premium and the equity premium. And this sensitivity matrix summarizes those points. You have the fundamental factors across the top, the liabilities and proxies down the left-hand side, and you can see the ones that have a positive large sensitivity is growth to wages growth and equities, and the remainder have a negative sensitivity that have components of inflation in them. So when one increases, the other falls.